Alright, so problem 29. Now we want to use SAT math scores to estimate verbal scores. So what we're going to do with this whole deal is we're going to take this graph here, it's given right there, and we're going to switch these two variables. So math goes down there, verbal goes up there. Okay? So the first question is, what would the correlation be? Well, remember this. Correlation is the sum of z of x times z of y all over n minus 1. So what are we doing really? All we did is switch x and y. But the z-scores are all the same. So all we did is switch the order of multiplication. So how did we change this? Well, we didn't. The correlation's not going to change. So our correlation in the last problem was 0.685. So our correlation in this problem as well is going to be 0.685. So R is going to be 0.685 because when we multiply it doesn't matter. Okay? And then it says in B, we got to write the equation of the regression line. Okay? So remember what we did in the last problem? We did this, right? So here's what we're going to wind up doing. These are going to become the y's, these are going to become the x's. So x bar of verbal is x bar sub math. I'm sorry, I'm using math now to predict. So math becomes the x is 612.2. Standard deviation is 96.1. Okay, and y bar for verbal is 596.3. And the standard deviation of verbal is 99.5. So we're going to go through the same deal, okay? The slope equals r times standard deviation of y over standard deviation of x. So the correlation is 0.685. The standard deviation of y is now our verbal scores, and our math scores are now 96.1. So if we do that out, we get approximately 0.709. Okay? And then we know that y predicted equals b sub 0 plus b sub 1 times x. Well, we know that the line goes through the point x bar, y bar, right? So we're going to put this in for x. This is our x value. That's our y value. 596.3 equals the y-intercept plus the slope, 0.709 times 612.2. And if you do that out, you're going to get the y-intercept. It's going to wind up being about 162.11. So, what's the equation of the line? Well, predicted verbal equals 162.11 plus 0.709 times math. That's it. Okay? So that's B. And then in C, what would a positive residual mean? Okay, well, residual equals actual minus predicted. And in this case, we're talking about math scores. So what does that mean? It means that the actual was better than predicted. So that means that the student did better than expected. That's what that means. Okay, that's what a positive residual means. So now, the person got 500 on math. So what's her verbal score? So we get 162.11 plus 0.709 times 500. And if we do that, we get 516.61. So the model predicts the student will score about 517 in verbal when they score they score 500 in math. Okay. Question E, using that predicted verbal score in the equation, you create a predictor math score. Okay. So if we put in this equation that we did in the last problem right here, and we're going to just put in the 516 or the 517 into that. So what we wind up with is, we wind up with predicted math equals 217.692 plus 0.662 times 517. And you get about 560-ish. 560-ish. So the model predicts that they'll get around to 560. Okay, so why doesn't this come out to 500? I mean, what they're saying is, in this model here, you put in 500 and you got out 516. But then you went back to the other model from the last problem to predict math and you put in the 517. It should go back to 500, right? Well, no, because these are predicted amounts. And what you did is you took a predicted amount and stuck it in here for an actual value. So you can't take predicted amounts and stick them in an equation for an actual value and expect it to come out with the exact same result. So the whole conclusion of the thing is you can't use the model in that way. You can't put this value in there.